Hello everyone, I am Akanksha, a final year student of Bennett University. In this video, I'll be talking about the project I've chosen to work on in these 4 months of my final semester. Practical and industrial exposure play a significant role in a student's development, both technically and interpersonally. As we know that 2020 and 2021 have been really challenging due to the COVID-19 pandemic. However, the work from home technology has been a boon to many in terms of becoming a better version of themselves while keeping safe at home. Likewise, I have utilized the last 4 months, practically the last 4 months of my engineering, in working on an R&D project at Bennett University. So, without much further ado, let's dive into what the project is about and check how it has been implemented. Security is an emerging paradigm which has achieved predominant importance in every field. The key objective of human security is to prevent the occurrence of risks or threats and focus on early action. One such area that requires prior action in order to ward off loss with respect to both life and property is surveillance monitoring. As we look into the problem statement, we see that recognition of human activities is a challenging problem in itself, owing to the varied activities a person can perform and also the varied ways in which a single activity can be done. Many approaches have been proposed with a view to solve the task at hand, but very limited seem to focus on infrared spectrum. Therefore, the need for an efficient recognizing system in infrared scenarios persists. As we analyze the requirement of this system in today's world, we can say that various businesses and organizations set up surveillance systems for their safety and security. Many smart surveillance systems are introduced into the current market regularly owing to the huge demand for surveillance and monitoring of footage. This is where this project can grab an opportunity to provide a solution with respect to recognizing human activities. This solution focuses on detecting different activities in infrared scenarios. Enabling a feature that can recognize human actions has its own benefits. It can recognize unusual activities and can deter threats which might have occurred otherwise. It reduces the human effort required to continuously monitor the CCTV footage and automates the process of monitoring and brings down the need for hiring a large number of people for the same task.
Existing approaches make use of sensors like infrared sensor or motion sensors to recognize human actions. Such sensor-based approaches are tied up with constraints like cost and various other resources. Furthermore, use of such sensors might tend to provide unnecessary false alarms even for minute movements. Other approaches based on visual imagery focus on monitoring indoors with a view to help the elderly. Also, less work has been done in the field of infrared spectrum for recognizing human actions. Therefore, with a view to provide an efficient solution to this problem of activity recognition, this project has been developed. This project focuses on the recognition of human activities, especially from IR surveillance videos. The primary goal is to correctly classify human actions that take place at long ranges from surveillance cameras. For this, various techniques of machine learning and deep learning have been implemented to perform the tasks of detecting, tracking, and also recognizing the activities they perform. The outcome of this project is a developed activity classification system for IR surveillance scenarios. The system contains modules for detecting humans and classifying their activities in infrared scenarios. The system can also be useful in determining if the detected humans are acting suspicious in the environment by checking the presence of firearms and guns. You can see the flowchart includes modules of human detector, gun detector, and a tracker and activity classification module. The flow represents how the IR video is processed until the results are obtained. Let us now look at the tools and technologies that were used in developing this project. The hardware requirements included a Windows CPU, an NVIDIA GPU for the training of the detection and recognition modules, and of course the surveillance cameras to obtain the CCTV footage. The software that this project was developed on is Python, and the libraries include PyTorch, Pandas, OpenCV, NumPy. Looking at the implementation, we have 4 different modules in the project, namely human detection, gun detection, human tracking, and activity classification. Let's look into how each module has been implemented in the further slides. So the first module that we can talk about is human detection. It has been implemented using YOLO v5. The module deals with detecting humans from the given input video. The input from the surveillance cameras is given to the YOLO v5 detector frame by frame. The detector then takes each frame of the input video and processes it to give human detections as the output. The entire system has been implemented in PyTorch, and the v5 version of YOLO, which is a PyTorch implementation as well, is believed to perform better than the other versions. Hence, YOLO v5 has been used as the object detector for the module of human detection. Next up, we have the firearm detection module, which deals with the detection of the guns from a given input video. For this module, YOLO v5 has been trained upon various gun datasets. The YOLO v5 object detector takes each frame from the input surveillance video and looks for the presence of gun in it. More specifically, the detections obtained from the human detector are cropped and sent as inputs to the gun detector module. The gun detector takes in the cropped human regions as the input and detects the presence of gun within the region of humans marked by bounding boxes. The detections of the gun are also obtained as rectangular bounding boxes around the guns. Next, we have our activity classification module. This module has been implemented using 2 different approaches. One is the image classification based approach, wherein individual frames have been sorted out according to the posture within the frame, so that the classification module takes in each frame and, depending upon the posture, classifies the posture into one of the predefined classes. The second approach that was worked on is a classification based approach based on the sequence of images. In this approach, instead of a single frame being treated as a classifying entity, we treat a sequence of images, or the sequence of continuous frames obtained from the human detections, as an input to the classifying network. For the implementation of this sequence-based approach, temporal shift module has been incorporated. The temporal shift module has proven to give better results just like the 3D CNNs, but at the complexity as that of 2D CNNs. This makes it favorable to be useful even in real-time scenarios. This module of activity classification takes in the input after the humans are detected and outputs the action that is being performed by them. The next module that we have is the human tracking module that associates a mapping between the detected humans and corresponding activity being performed by them. For the implementation of tracking, the state-of-the-art tracking algorithm DeepSort has been considered owing to its favorable results in real time. This module considers the human detections, and once a person is detected, a unique track ID is associated with the bounding box of that person. To determine the relation between new ID and an existing track, Mahalanobis distance is taken into consideration. This distance is set to a certain threshold value, and if the distance is greater than the threshold value, a new track ID is assigned to the new person. And if the distance between the detection and an existing track ID is lesser than the threshold that is set, the track ID of the person remains the same. In this way, the DeepSort tracking algorithm works. The cropped human regions of each frame are obtained to form a sequence of 32 continuous frames. In case of multiple people appearing in each frame, the DeepSort algorithm works as the tracking framework to provide individual or unique track IDs for each individuals present in the frame. Therefore, the sequences of 32 frames that are obtained are fed into the action classification model implemented using the temporal shift module. The temporal shift module classifies the action within the sequence into one of the predefined classes. Simultaneously, the detection for the guns is also carried out for each frame along with the human detection. A sample image of the results obtained has been shown as visualization. You can see two people being recognized as persons and their actions being classified as HL, which means humans are loitering, and the deep sort algorithm has successfully categorized the two persons as two individuals, giving them different track IDs. To maintain confidentiality, the details about the datasets or visualization of the results are not yet included in this video. Although the previously mentioned challenges were encountered, we could achieve the desired results and develop a unified, robust, and efficient activity recognition system, which can be used as a smart surveillance solution. The system has seen to achieve good performance in recognizing human activities with low latency. The system has been automated to identify human activities and the presence of guns using deep learning techniques. Since less work has been done in the area of action classification and recognition in infrared surveillance scenarios, this system can stand as an efficient solution which can be relied upon. So that's all about my final semester project at Bennett University. I hope that this work can be published soon so that I can share the links of the work which would contain information related to this project in much more detail. Thank you for watching. Please like if you find this video useful. Also, you can email me at the address provided here if you have any queries. Thanks for watching.